Welcome to the stage, David. David?
Yes, David.
David and Ahti. So guys, I'm going to be honest with you. I'm not an expert in the future of logistics.
You will be in 20 minutes.
Awesome. Amazing. That's what I'm hoping for. So most of the onus is actually on you as the experts in the field to kind of to help me express what that future is going to be like and how you see it. So I think like Ollie and Starship are both kind of ground-based innovations in the sense. So one question that I have that I've asked of people before about Starship is why logistics on the ground when there's so many people taking to the sky?
So I think there's an answer to that. I think the people, like the drone people, I think that's what you're referring to, who are kind of taking to the skies.
Yeah.
I think that started a bunch of years ago when the ground autonomous vehicles were not as advanced yet, and then people thought, oh, it's really easy up there in the sky, right? You can just, fly straight line. You don't need any of this autonomous crap. Any of these, not really like safety issues. Like you don't collide into people, and these things. And drones already exist, right? You can fly a drone. I mean, it's really really simple to actually program a drone to fly in a straight line. So it's kind of everything already exists. But of course, there are some small details, of course, small problems, right? Like safety. What if this actually falls down? And regulations, and the interactions with the airplanes. Like it's actually a big danger, right? And the economics. Like it's actually not cheap to fly a drone like reliably. I think. Like 5 years ago, people kind of ignored these problems a little bit. They kind of thought that okay, these will get sorted out, right?
Yeah.
It turns out the ground autonomy is being sorted out faster than these problems. So now we are actually living in the reality where I think Starship is probably the company with the most experience in the world doing autonomous deliveries. Like we are doing thousands of deliveries all the time with our like actual service, and the drone people are still like mostly talking. And I'm not sure what your perspective is.
Is this on? Okay, good. All right. Good morning, everyone. Well, good afternoon. In America, it's really early morning. But it's interesting because this is the first time I've met you, even though our companies in the U.S. are separated by a couple of miles in the Washington, D.C. area. He's in Virginia. I'm in Maryland. And just on the topic of technology readiness, whether it's air mobility or ground mobility, I think the biggest hurdle is actually whether governments and municipalities are ready to deploy it. So to give you an example, one of the reasons why we in Washington, D.C. area on the ground or focused on the ground is because there's a thing called the red circle or the red zone, which basically says if you're within 5 miles or 15 miles direct line, it's kind of a big range for certain things. You can't operate because it's the White House and the Pentagon and other things. So the FAA basically has created a no-fly zone for pretty much any and everything that's not military or major commercial service in and around DC. So those are some of the other issues that, whether it's ground mobility or air mobility, that are causing the constraints of the technology being ready. So obviously the technology is somewhat ready, but the bigger issue is the regulatory front. And even on the regulatory front for ground mobility, we have a significant amount of hurdles because, Starship doesn't fit into an existing vehicle classification, nor does the Ollie from Local Motors fit into an existing. So there's a lot of hurdles on the regulatory front to still overcome to put this technology to use on a daily basis.
Yeah. One common theme between Ollie and and Starship that I know of is that there's actually, even if secretly, there's a person involved in there. Ollie there's like a supervisor kind of manning the
steward.
Okay, a steward, yeah. And Starship has some people behind the scenes watching whatever shenanigans are going on in front of the robots. So I'm curious, like, how far away are we from those people not having to be involved, or at least limited?
With Starship, it's like we are doing it selectively.
Yeah.
So sometimes people are supervising what the robot does, but most of the time they are not.
Okay.
So that's a change from the situation that it was like a year ago or 2 years ago. 2 years ago, actually, we all the time had even if the robot was driving autonomously, all the time had somebody supervising. We actually 2 years ago we had often one person supervising in a kind of a teleoperation way, like sitting in an office, and either in Washington D.C. or in Tallinn, and another person following the robot. Now we no longer have the people following the robot, and most of the time also the supervisor doesn't supervise the robot. So that's also where the economics comes from. Like the drone regulations, it's still mostly like okay, you can fly, but you have to have this line of sight, right? In the ground, like in case of our robot, there's usually no such requirement. So yeah, we cannot go we can go actually closer to Donald Trump than 15 miles, but we can go up until 1 mile.
Yeah.
Like that's about about the agreement we have with Washington D.C.
Right. You have to get an exemption.
Yeah,
There's ways to get, but you can't just go out
anywhere,
and fly your drone. But that's like in some places, in Montana, you can do whatever the heck you want to potentially with a drone. So my point is, in the urban density, you still need special permits, or there's potentially no permit. In terms of the Ollie steward conversation or supervision, in the future, Ollie will still be supervised. It will be more like a teleoperator, where a person maybe supervises a fleet of Ollies that may range from 10 to 20 vehicles.
Okay.
Because you'll need supervision for a variety of reasons that you wanna engage customers and consumers to make sure that they're comfortable. I think the question about when will a steward be finally or firmly removed from the vehicle depends not necessarily so much on technology readiness. It depends more on customer and consumer preference, right? I'm sure that 100 years ago when we had, lift porters for elevators, probably they were able to leave the elevator for a long time before they actually left because of the consumer preference and comfort. Like, there's another person in here that's gonna press the button for me and make sure, and they do this every day, so I feel safer. Right? And I think the same thing can be said about a presence of a safety operator or steward on a vehicle. Obviously, for the economics to make sense, I think down the line, a lot of people want to remove that operator because that's an additional cost. But I think as we redefine the experience, which is what I mentioned in my talk up on the big stage, there may be a purpose for a person to be in that vehicle that's beyond safety operations. It may be a concierge type of service. It may be a informative type of service. It may be a customer experience type of service that organizations will still have people or a person in the vehicle to engage the consumer, to enhance the experience of what they experience while in the vehicle. So it may be removed from a safety perspective, but they may still remain on the vehicle.
Interesting. Okay. This kind of broke my next question a little bit, but maybe you still have some opinion on the topic, because as things do become more autonomous and we do remove maybe the steward or maybe not, what is the impact of that on the job market? This is a big topic and kind of the controversy that spurs when you have these conversations about autonomy and robots and all kinds of this sort of thing. So for you guys, do you feel like you're stealing jobs?
I would. So I think technology, and I always put it in historical context, right? Technology over the last thousands of years has always change job markets, right? We used to be an agricultural economy, then we became an industrial economy, then we became a internet economy, now we're becoming a digital economy, right? And so we've always had technology change and displace jobs. That will happen again. So there's an organization called SAFE in America called Securing America's Future Energy that just about 6 months ago released a report that said the net economic impact of autonomous vehicles by 2050 are going to be $780 billion, which is actually including a net job increase. So the point is that I think in the short term, there will be actually, drivers are continuing to be needed, especially in a world where you have dual modes, autonomy and non-autonomy, or self-driving and non-self-driving. So there'll be actually an increase of driver jobs or safety operator jobs that will be needed. And then in the mid and long term, there will be displacement. And it'll change from driver or safety operator to providing a concierge service, to providing customer service, better customer experience, and so on and so forth. So I don't know if we're going to steal jobs, but we're certainly going to displace jobs.
Huh.
Yeah, I also agree that these new types of mobility opportunities, they also create new economic opportunities. Like in the case of Starship, we are making the local delivery of things, essentially free and really quick. And the local delivery, that means delivering something from your local corner store to your home. And your corner store didn't have that opportunity before, or well, actually they did have, but it was really expensive. Mm-hmm. They could actually hire a person to sit around, and whenever you kind of order something, then the person runs to you. But it wouldn't be economically, it wouldn't make sense. You would need to pay, let's say, $10-15 for this. People are not really prepared to do that, and therefore there is more economic opportunities, and I think we will be in general increasing business for the local merchants and the stores that we are working with, which should result in actually job growth. And in general, I'm not sure what's the situation with bus drivers, for example, but in couriers or in urban logistics, generally it's a shortage of workers. Generally, it's like people, companies can't hire enough people. There's so much demand. Yeah. So I think initially we'll be taking on this extra demand, and I don't think really that people will lose their jobs. Really, it's just such a growing market.
Yeah, interesting. So then I guess the broadest question of the panel is really, and I want to get into Q&A, and I like to do lots of that if possible. But the discussion topic itself is really, what do you guys see as maybe even beyond Starship and beyond locomotives, like locomotors? What do you see as 100 years out? What is the next evolution of logistics? What's interesting for you right now, or exciting for you that you see might happen?
Well, I don't know. I'm going to be careful about trying to predict 100 years from now. Because technology, that I was at a presentation a couple of days ago where they talked about, it took something like 100 years for the first 10 million people to get the telephone, right? And then it literally took 13 days for the first 10 million people to get Angry Birds, right? So just imagine that. So I think there's going to be a crap ton of stuff happening in 100 years versus the last 100 years. Yeah. So I'll be careful this. But what I think will happen, and it goes back to your first question, is that urban air mobility and urban ground mobility will start converging. Okay. And what will happen is you'll get to a place where the FAA, the FCC, and the ground mobility people, like the NITS, I'm talking USA, whoever the appropriate authorities are in other countries and regions around the world, will start merging, the FAA, which regulates where people can fly, the FCC regulates spectrum, which is obviously needed from a communications perspective to make all of this connected digital work, and the people who regulate what gets on the ground will start figuring out how to take a systems approach. And when you start taking a systems approach, you can get an Amazon drone to drop its package on a Starship drone to go and put it to the front door. Because in some places, that Amazon drone may not be able to fly because of Washington, D.C. regulations. So it needs that Starship drone to take that package from a 10-mile journey to the last 50 meters or 100 meters or 1,000 meters, whatever it is. And the same thing from a people perspective. You may have an Ollie take a group of people to a launch pad that takes a sky taxi from that last mile to now I'm taking a sky taxi from Washington, D.C. to Baltimore, which is around a 30-mile journey, right? And so those things, I think, will begin to converge. Just like with, 10 years ago, lots of technologies and regulations converged to enable this iPhone, where now I have an app with online check-in, with search and Google, and all of these other technologies that enable this will start converging to enable the future. And I think that isn't going to take 100 years. That's going to take probably 5 to 15 years to go and happen around the world. And places like Estonia, I think, are going to take a leading role because they really want to be on the cutting edge of bringing like the use cases and testing here to enable that future. At least that's one of my perspectives.
Yeah, I also will not really do a prediction over 100 years, but shorter, yes, exactly what David said, like 5, 10, 15 years. I think it's much easier to predict because the things that will be really popular in 10 years or 15 years, some of these things, like the seeds of that, we are actually seeing already right now, right? In like smaller, much smaller scales. So we of course have autonomous vehicles, autonomous buses, which are kind of in smaller scale to some extent working, right? Then we have the sort of sidewalk delivery robots that we are building, and then we actually have flying cars, and we have sky taxis, which are some companies are developing, and they're sort of like in advanced prototype stage, or I think you can't really buy one yet, but it's actually pretty close. Like probably next year you actually will be able to buy a flying car probably, and so these things are really sort of small scale right now, like in terms of like popularity in the overall world. Like very, very small fraction of people have kind of experienced this, but they already exist, right? So it's quite safe to assume that in 10 years from now, these things will be really popular because they provide undisputable benefits. And even if this like one company fails and doesn't deliver on their promise, somebody else will. There's no fundamental reason why none of these will not be really popular, let's say in 10 years. So it's quite clear that these will change other things. Then you can actually start living like Peter Westerbacka said in the previous panel, that the vision of France is no longer that everybody should live in a farm, and you can actually live on a farm 20, 30 miles from Paris, and you can actually commute to Paris all the time using your flying taxi, right? And your own flying car, and that will actually be a reality probably in 15 years.
Flying tractor,
right?
maybe. Yeah.
Flying tractor, yes, maybe.
Right.
So this will change actually a lot of things.
Okay, interesting. I want to ask one little bit weird question, but I like to be involved in I like to listen to people like you two talk to each other. So I'm curious whether or not either of you have a question for the other one, because you're the ones who are the experts and the ones with the interesting insights. So I'm curious if either of you have a question for the other one, and that's a lot of pressure all at one time.
No, it's interesting. So
I need to drink first.
Yeah. So it was really interesting. 2 years ago, this was mid-2016, I think you guys came to Washington late 2015, right?
Something like that,
yeah. So you had just, they got made the Washington Post or some local newspaper. It was big news, like delivery robots, and it's coming to Virginia, and so I had heard of you, and then I was hosting the USPS, US Postal Service, and their innovation digital team. And they came to us and basically said, hey, by next May, so this was summer of 16, by May of 17, they want to go and develop basically their own delivery robot, which was, I think, spurned by Starship. And they were very interested in us because they wanted us to 3D print the first prototype. So from what I'll ask you is, what are you looking at in the future in terms of making and manufacturing and producing? Are you gonna, produce it in China and ship it everywhere, or are you gonna try to make it locally, whether that's Estonia or Washington, and really give flexibility from a local perspective?
I think there's an easy answer to that. Like, right now, we don't know, because we have manufactured I think 250 robots or something like that, and we have done the final assembly actually here in Tallinn for all of the robots. Obviously, this is not what we are going to do when we have like millions of robots. We do not have the manufacturing capacity. Here.
You'll crank up China.
To do that.
That's
So we will find the solution. You are the experts on this. Maybe we can actually learn from you how to do that, or work together to do that. But there's definitely going to be, yes, it's probably either of the options you mentioned. Maybe both, yes.
Yeah, because certain things you want to scale.
Yeah.
And always is going to make sense to scale using traditional manufacturing at your lowest cost possible. And certain things you may get, like an Amazon approaches you and says, I want 100 delivery robots just for this market and just in this form factor. And you're like, well, I can't make those in China because that's too costly for me to tool up for 100, but I might make them in the microfactory in Local Motors in Washington, D.C. So we can work together.
Yeah, it could be something like that, that for sure. Like we are at the stage where the mass manufacturing we have not really worked with at all, or we have very, very little.
Yeah.
We have done very, very little there. But we will need to also get better at this as we plan to scale our service.
Understood.
Interesting. Very cool. I think. Do you have a question?
Yes. So the question I have is around the oily.
Okay.
And so do I understand correctly that you started developing this from the standpoint that, okay, let's make this kind of small bus type of vehicle and autonomous, or did you have a specific use case in mind already from the very beginning, that there's a very specific attractive market that you are developing this for?
No, see, that's not. So I'm gonna say no to both. Right? So we started how we start most of everything, which is we start with a blank sheet that says, we want to go and work with local communities to develop solution based on their needs. Right? So when we started the process that eventually led to the Alley, we had worked with Berlin in 2014, the city of Berlin, not like an individual, the city of Berlin, Germany, in 2014, and as several stakeholders that represents transit, jobs, the local government, and a number of other public and private entities in Berlin, and said, what are you thinking about? What concerns you? Because Berlin in that time frame and still now, is a booming town. There's construction everywhere, there's congestion, there's people moving there, they have transit, but they also have too many vehicles and all kinds of issues. So what concerns you? And they said, look, we really want to think about what does mobility look like in our city in 15 years, right? 15 years was 2030. So we created a challenge called the Urban Mobility Challenge 2030. And we launched it in early 2015, and we basically said to our global community, which resides at launchforth.io and represents around 200,000 members in 150 countries, and said, come up with solutions for a place like Berlin that has this demographic, these challenges, as it relates to moving people, as it relates to moving goods, and as it relates to infrastructure to support both. And we opened that challenge, and we had a 22-year-old Colombian design student who was studying in Italy come up with the Ali concept, and at the time it was actually called the Berlino. And he won first place in both the category for moving people and moving goods, and then he won the overall challenge. And that became the concept vehicle that led to the Ali in 2016. So that's how it works. It's like we try to use a global community to think about solving local problems. And we bring various people together that may have never been to Berlin, but can imagine what it may be like based on their own experience to then develop solutions for those local challenges.
Okay, so you kind of took this first place idea and started implementing this.
So the way it works is, right, the way our CEO, Jay Rogers, who co-founded Local Motors and about 10, 12 years ago, says it is, at LM Industries, which is the parent company, we have Launch Forth and Local Motors. And Launch Forth helps cities, large organizations, ourselves, see through the cloud, right? And so we use our community to help us develop concepts that are kind of foggy, right? That aren't clear. And then they work to develop a prototype. And so that normally happens in less than a year, which is kind of a really compressed timeline for developing complex transportation solutions. So the most recent example, we did this for the Marine Corps, the US Marine Corps of the Department of Defense. And we went from a concept to a prototype in less than a year. And the last time anybody did something in the Defense Department in less than a year was never, right? And so that's what happens at Launch Forth. They go from concept to production-ready prototype in less than a year. And then if we see that there's demand, the Local Motors team takes it over and says, all right, I'm now going to take this from prototype and I do the systems engineering and integration and take it to a pilot vehicle that we can actually build in one of our microfactories and then see if we can scale to a production version. So that's kind of how the process happens over a 2 to 3 year period, which is much faster than traditional vehicle manufacturing and development, which goes from concept to production ready in kind of 5 to 7 years.
Yeah.
Awesome. So I want to thank you for that, by the way. That was really cool. I want to take a couple questions from the audience before everything is run out. So we've got one here, one question here, I think.
Yeah, hello, Peter, currently freelance, but the question is about accidents caused by autonomous vehicle and responsibility today and what you see in the future. I think the regulation today is a little bit maybe not very exact, but just an example I've been bringing before. In LinkedIn was a news where is on shopping mall replaced a security guy with a robot, which is human size and driving with wheels. So first time it was in news when a robot was attacking a small girl because she didn't behave human way, yes. And the next time it was a picture as well. This robot decided to commit a suicide. So it drove during the night time to the pool in the shopping center and drowned itself. So the accidents happen, yeah, but who is responsibility?
Well, ultimately, the responsibility is either with the operator or the designer of the vehicle, for sure. And this is, I think, how things are regulated, right now. In general, about safety issues with the autonomous vehicles, I think overall it's relatively clear that even autonomous cars and autonomous buses, which are big, they probably will be safer. They probably already are safer than the humans right now. Let alone small vehicles like our Starship robots that it's much more difficult for them to actually hurt anyone even if they wanted to. But I think there's a bit of a perception change that is likely, I think, to occur. I think 2 years ago people were really saying that okay, what if this autonomous car actually kills a person? people were like fantasizing about that. Okay, what would that be? Or that would be like terrible. And of course it's terrible. It has already happened, right? Like a few times, depending on what cars are we counting in, and also the robotic security guards. Of course, there are security and safety issues with them themselves, of course, but still, I think in the end they are probably safer than the humans, or that's why they're being developed in the first place. And I think. Like a couple of years ago, there was more like, this would be terrible the first time it happens. The thing is, now it has happened. And I think people are, coming around to the conclusion that, okay, it does happen, but they're still safer. So I think that's a change that will happen. And also I think you were referring to the Nightscope incident that they had in this Stanford shopping mall, I think, that where the robotic security guard collided with a kid. I think the kid kind of got a bruise or something like that, but was not badly hurt, I think. And if you count the number of hours this robotic security guard had worked, all in total, I think it wouldn't be unrealistic to actually expect that a human security guard would also kind of by accident like run over a kid or you caused like a bruise or something like that, and of course without wanting it in the course of their work. So I think I'm actually quite optimistic in the safety aspect.
So we're just over time. Let's take one more question at least. Yeah, maybe two. We'll see. See if I get yelled at.
Lady in red. Okay, gentleman in blue.
Lady in red next.
Hi everyone, I'm Simon from Precision Navigation Systems. I have a question. For autonomous cars, autonomous machines, there are a number of technologies that these cars are having, like LiDAR scanners, Parktronics, GPS, high precision GPS, and sometimes these technologies are different that are used in different machines. Sometimes they're in combinations, like one is added to another one. What's your view on that, and which technology or set of technologies will be used in the next couple of years, which mix will be the primer one for using in this type of machines? Thank you.
So I think there's, sensor fusion is a key aspect, and it all revolves around redundancy in the system, right? And so some organizations are choosing to go, camera, LiDAR based as their primary sensors, and then with GPS and radar as redundancies, and then human operators as kind of normally there are 2 or 3 layers of redundancies to ensure safety. In our case, we use primarily LiDAR and radar, and then we have cameras and GPS as backup, as redundancies. And so it just depends on what use cases you're deploying, as well as what safety factors you need, and then what cost you can bear within that use case, right? Because certain technology, like LiDAR, is relatively expensive, even though there's new organizations out there like Luminar Technologies and Ouster and a couple others that are really trying to bring the cost of LiDAR technology down. So I don't know where you'll wind up. I think it depends on a lot of what your particular use case is that will determine what really your sensor suite will be and how you integrate those sensors to deliver your capability. But it is a matter of combining software and hardware into the appropriate technology suite to address your use case in a safe and redundant system.
Yeah, I also think the answer is really varied, or there's probably not going to be like one single magical sensor that everybody's using. It's the good news for the makers of the vehicles is that there's so much variety right now, and kind of on the offer, or there's so many companies developing new new types of sensors which seem to have like magical properties and so forth. The bad news, of course, is that a lot of them actually turn out to be duds, or actually not having these magical properties that the designers were saying they will have, or they turn out to be like 5 years late and 5 times more expensive than projected. But I think I think in my own experience, I can single out probably I think 2 kind of types of sensing which are, let's say, I think receiving a little bit less attention than maybe they should, and one of them being time-of-flight cameras or depth cameras that can essentially give a 3D picture of the scene, like really nearby. Like LiDAR is much more expensive, but LiDAR is for like 100 meters, 200 meters. That's where it's really good at, or like much better than other sensors. But time-of-flight cameras are actually really good in like the first like 5 meters or 10 meters or something like that. And this is actually going to be cheap, or quite cheap, and
inexpensive.
Inexpensive.
Yeah.
Okay. Yeah, and
cheap seems like
yes,
not
and
safe.
and there are opportunities there. I think these will be used for in many different applications. And also the other thing I think that's kind of obvious. I think, but essentially image recognition based on neural networks. This. It probably will be the case, like, it's like really, could be like really commonplace. Like I take out, my smartphone here, and, right now my smartphone, does not understand, where I am. Like I'm on a stage right now, it doesn't understand, who is this person here, It doesn't understand who is this person, that there is a person. But, it actually probably will be the case that, in 5 or 10 years, your phone, for example, is always aware of what's going around you. It actually recognizes you. Ask me to add you on Facebook. Like after I walk off the stage, for example, and things like that. And so these kinds of things will be, I think, commonplace. Like right now they're like technology demonstrators. They're used in. Yeah, there's some apps that are using this kind of stuff, but it will be really commonplace.
Ahti, I have to step in right now because we have to go on with our next panel. So guys, thank you so much.
Thanks, guys. That was awesome.
Yeah.
Thank you.
Thank you.
So, applause for them.